Okay, so what we're gonna study today is object-oriented programming with C++. And these are the chapters which we're going to cover in this unit. It's introduction to object-oriented approach, classes and objects, polymorphism, inheritance, exception handling, and templates, IO streams and files as well. So these are the books which you can refer, but at first, introduction to object-oriented approach. Chapter 1, Introduction to Object-Oriented Approach. Why object-oriented programming? So you see, in object-oriented programming, there is a class, and that class is basically a template used to make similar objects. For example, there is a student class. So the student class is going to have attributes of a student, which are his name, his class, his section, and you can use this template to make students that will be objects which will have these attribute values set to something. So that's a very basic definition of this object-oriented programming. Yeah, object means a real-world entity such as a pen, chair, table, etc. Object-oriented programming is a methodology or paradigm to design a program. It simplifies the software development and maintenance by providing some concepts. Why? Now we're gonna look why object-oriented languages are used. Is because they allow to break the program into best size problems that can be solved easily. So essentially you have a big problem, such as you have to make 100 students, a list of 100 students and their marks and class. You basically need like a database, right? So you can break down this problem into class and objects, which will help you to achieve this. New technology promises great programmer productivity, better quality of software, and less maintenance cost. Object-oriented systems can be easily upgraded from small to large systems. So this is just the jargon. This is the history. I don't think you really need that much, but yeah, you can read if you need to. Now we're gonna look into procedure programming approach. So at first, this is what was used in programming instead of object-oriented. The high-level languages such as COBOL, Fortran, and C are commonly known as procedural-oriented programming. In the procedure-oriented programming, the program is viewed as a sequence of things and a number of functions are written to accomplish these tasks. The primary focus is on functions, procedural programming methods. Each problem is divided into small problems and solved using specified modules that act on data. So procedural programming is not object-oriented. It was the one which was used before. For example, in C language this was used, but in C++ they added object-oriented concepts. So this is not exactly in our syllabus, but it's useful to know. So basically what we have is a program, and we have divided it into multiple parts. For example, there is a program which calculates the sum of two numbers, right? So we can divide it into functions. Functions are basically different blocks of codes which can be called and executed by the main program, right? So the function one can be a function which asks for user input, and the function 2 can be which adds the both numbers, and function 3 prints them, right? So this is structure of object-oriented procedural oriented programs. In multifunction programs, many important data items are placed as global so that they may be accessed by all the functions. Each function may have its own local data. Figure shows the relationship of data and function in a procedure-oriented program. So basically, what happens here is, like, there is some global data. For example, there is global variables which are defined, and they are data which can be accessed by any of the functions. So this, for example, you asked for input of the student details like its name and class. So this is, if this is stored in a global variable, it can be accessed by any function inside. So what will happen is, multi-function program, these global variables will be accessed by different functions to like use them in the program. Now procedural programming characteristics, they have emphasis is on doing things like algorithms. Algorithms are basically set of procedure which you need to like follow to get a specific task done. Large programs are divided into small program functions. This is already told, like if there is a bigger problem, you can divide it into smaller parts and handle these smaller, easier parts to tackle the problem one by one by breaking it down into simpler parts, right? Most of the functions share global data. Yeah, this is also an important point. Like I told before, the data is global, which means it can be accessed by any functions. Data moves openly around system from function to function, which means there is, like, for example, that student program, right? That you can input, you can make a function for input, and then you can make a function for processing, which is like addition, and then you can make a function which displays the result. So the data is the student details, which is first entered from a function, and then it moves to another function which adds them, and then the third function which displays them. So as you can see, data is moving openly around system from function to function. Now the next point is function transform data from one form to another. So yeah, it again, the student example, like the function which are input, output and addition, they are basically transforming from one to another. For example, you input one in one variable, you can do the addition, and so addition is basically the transformation of data here, right? Employs top-down approach from programming design for program design, which basically means that you are taking a big problem and then breaking it down into easier parts, easier and smaller parts, tasks. So that is the top-down approach. Limitations. In large programs, it is difficult to identify which data is used for which function. So yeah, this is, procedural programming is good, but it's not, it has these limitations, such as in large programs. To revisit an external data structure, all functions that added the data should also be revised, and maintain and enhancing program code is still difficult because of global data. So for example, you have global data set to int, and if you are like editing the code, if you make an edit in a function, you're going to have to make edits to other parts as well to like compensate for that, so that they still work together properly. And then there is focus on data rather than focus on functions rather than data, which is because of the algorithm, they follow algorithms, so that is why. And the next point is, it does not model real world problems very well, since functions are action oriented and do not really correspond to elements of problem. We're going to see about this in a bit. The major motivation factor in the invention of object-oriented approach is to remove some of the flaws encountered in procedural approach. So yeah, as I told, in C language, it had many flaws which came with procedural oriented programming language. So object oriented programming language is here to fix those flaws. So C++ was made. Object-oriented programming treats data as a critical element in the program development and does not allow it to flow freely around the system. It ties data more closely to its function that operate on it and protect it from accidental modifications from outside functions. So basically the data is not as global, so which means that all the functions can't like access it, which helps protecting the data by like unauthorized access, and basically data is the central focus. Object-oriented programming allows decomposition of a problem into a number of entities called objects and then builds data and functions around these objects. The organization of data and function in object-oriented programming is shown in the figure. The data of an object can be accessed only by functions associated with the object. However, functions of one object can access the functions of other objects. So what this basically means is that object-oriented programming allows decomposition of problem into a number of entities. So they divide the problem into smaller objects, such as the problem of having a database of students. They made the class student and have object students. Build data functions around these functions. The organization of data and functions object-oriented programming is shown figure. So basically what this means is the data is oh my god, I'm getting distracted. Okay, sorry, moving on. Features of object-oriented programming. Emphasis is on data rather than procedures. Problems are divided into objects. Data structures are designed such that they characterize the objects. Function and data are tied together in a data structure so that the data abstraction is introduced in addition to procedural abstraction. So this is like this all we have already discussed, kind of. Data is hidden and can't be accessed by external functions. Objects can communicate with each other through functions. New data and functions can be easily added. Follows bottom-up approach. So these are the like features of object-oriented programming, which show the difference in both of these, right? So bottom-up approach is basically they have smaller parts and they combine them to make bigger parts, and then you finally have the program, right? Yes. Oh my god. New data and functions can be easily added because they are independent. An object can communicate with each other through functions. Data is hidden because it's not stored in global variables. Like they can talk with functions. Okay, so this is really simple. It's reusable because we have modules that are written by user and you can just like call that again. Inheritance is also reusability and data hiding because we are not having global variables. We are passing data through functions from one object to another. Complexity decrease, easy to maintain and upgrade because uh, you don't have to make as many changes to like make an update, right? Because you can just make an update to a class and then all of its objects will be edited on its own. Hmm. Message passing. This technique of message communication between objects make interface with external systems easier. I guess more difficulty. It's easy to make minor changes in data representation or procedures in object program. Changes inside a class do not affect any other part of program. The only public interface that external world has to a class is through use of methods. Okay, object-oriented procedural versus object-oriented. The merits of object-oriented programming. Length of program developed in object is much larger than the procedural approach. Why? Because making classes as well and procedural, you can just directly like write 2 lines of code. Since program becomes larger in size, it requires more times to be executed and leads to slower execution of program. So this makes sense, right? It makes a program simpler, easy to modify, but it also makes it larger and slower. Program needs to have brilliant designing skills and programming along with proper planning because object-oriented programs is a little bit tricky, which is the because of the complexity, right? Makes sense. Take time to get used to through process involved in object-oriented programming may not be natural for some people. This is the case for me. I like procedural more, but it's whatever. Everything is treated as object in object-oriented programming, so before applying it, we need to have excellent thinking terms in terms of objects. Characteristics of object-oriented programming language. Yeah, so we have classes, objects, encapsulation, data abstraction, inheritance, polymorphism, dynamic binding, message passing. We are going to look at all of these. So rest assured. Firstly, objects. Objects are the basic runtime entities in an object-oriented system. They may represent a person, place, bank account, number of table of data or any data that the program must handle. Fundamental idea behind object-oriented programming is to combine both data and function into a single unit, and these units are called objects. The term objects means a combination of data and programs that represent some real-world entity. When program execute, the object interact by sending messages to one another. Each object contains data and code to manipulate the data. I guess I've explained all of these points before, but I'm going to give another brief. So basically, right, we have the object student, and it's going to have the data, which is basically the student attributes such as his name, date of birth, marks, and other things. And functions are basically tasks which can be performed on this object student. And the object-oriented programming approach is to combine both data and function into a single unit. So we have this data which are part of the student object, and student object is made from a class, right? Oh my god, I have butchered the typing. I guess I'll just clean it up. So yeah, we will also have functions which are going to work on the data. Now a group of objects that share common properties for data parts and some program parts are collectively called as class. So like I told, for the student object stu, we can have multiple objects, right? Like student1 and then student2. These are all made from a singular class, right? Share common properties. So the student1 and student2 will always have properties such as names, class, and everything. Every data member is going to be stored, and some part are collectively called as class. In C++, a class is a new data type that contains member variables and member functions. Member variables and member functions that operate on variables. So basically what we have is we have a new data type. A class is the new data type. Basically, class is a user-defined data type, right? Which means, for example, we already have data types such as integers and float and characters, right? So these are system defined data types. A class is a user defined data type, which means that the class can be defined by the user. Oh my god, I'm butchering this. So basically, for example, a class student details, which has student details, is a user defined class which are going to have details about the students. So yeah, there is that. Next we have the entire set of data and code of an object can be made a user defined data type with the help of a class. So entire set of data and code of an object can be made a user defined data type with the help of a class. So the user is basically defining, right, that what properties a student is going to have. For example, the student also has name. A name is a string, and it also has marks. Marks is integer. So like that, we can have multiple system defined data types inside a single object, which is a student, and it is a user defined data type, and we can perform functions on it. Objects are variables of class type. So yeah, The data type of an object is the class. Class is the new data type, and objects are variable of the class type. So basically, like stu1, which is student1, this is actually a variable, right, of the data type student, which is a class. Once a class has been defined, we can create any number of objects belonging to that class. That makes sense, I guess. Okay. So this is an example. It shows like this S1 is an object and S2 is an object. Both are user defined data types which are defined by the class, and S1 is an object which has these values. It can have a roll number, it can have a class, and the roll number is an integer. Integer holds 4 bytes and name holds 3 bytes, which is like 1 byte for each character. Similarly, there is another object S2 which is of similar data type, which is of student, so it also have the same properties like roll number and name. Roll number is again an integer and name is basically characters. Now classes. Classes example, when class is defined, objects are created like this, like class name, object name. Class name, for example, student, and object name is S1 and S2. If employee has been defined as class, then statement employee manager will create an object manager, like object manager belonging to the class employee. So this makes sense, I guess. Encapsulation is the next topic. Encapsulation, wrapping of data and functions together as a single unit, is known as encapsulation. Wrapping of data and functions together as a single unit. So encapsulation is like a characteristics of object-oriented programming, which is what it is basically what we do when we create an object. So object has functions, like functions can act on object, and object obviously hold data. For example, data hold in a student class is his name and roll number, and we can perform functions on that. So it will together be known as encapsulation. By default, data is not accessible to outside world and they are only accessible through functions. Only this is also important. So as we have learned before, in procedural oriented programming language, the data is stored in global variables, which means they can be accessed from anywhere in the program. But in this object oriented approach, we are storing them in objects, which helps us keep them like private, like not accessible through other means. So basically it makes them more secure and only access through functions for those objects which are wrapped in a class. Prevention of data from direct access for the program is called data hiding or information hiding. So basically this is the concept of encapsulation. Next, data abstraction. Abstraction refers to the act of representing essential features without including the background details of examples. Basically, in abstraction, what we do is we just give the essential features, just what is needed is provided without including unnecessary background details or explanation. Classes use the concept of abstraction and are defined as a list of attributes such as size, weight, cost, and functions to operate on these attributes. They encapsulate all essential properties of objects that are to be created. Then the attributes are called as data members, as they hold data, and functions which operate on these values are called member functions. Okay, so the attributes are called as data members as they hold data, and the functions which operate on these data are called member functions. So basically I told you, right, there is a class, it's going to make objects, and the data members are basically like students, and it's going to have data such as his name, his roll number, right? Because this is the data, and functions are going to be the way by which we are going to access this data and like work on this. For example, roll number and marks can be averaged by using functions. We're going to see it in program. Class use the concept of data abstraction, so they are called abstract data type. Why are classes called abstract data types? That is because class use the concept of data abstraction, so they are called abstract data types because they use abstraction, which is basically just showing the essential features. That is why classes are called abstract data types, which are also user defined. Now inheritance. Inheritance is the mechanism by which one class can inherit the properties of another. It allows a hierarchy of classes to be built, moving from most general to the most specific. When one class is inherited by another, the class that is inherited is called the base class. Inheriting class is called derived class. In general, the process of inheritance begins with the definition of a base class. The base class defines all qualities which will be common to any derived class. In OOPS, the concept of inheritance provides the idea of reusability. In essence, the base class represents the most general description of a set of group traits. The derived class inherits those general traits and adds properties that are specific to that class. So basically what this means is that you are going to have a class, for example students. This will be the base class which will describe how a student should like be. Now for example you want to make another class which will be its child class. Now why will it be child class? Because it will like take properties of the student class into itself without being explicitly defined. So you don't need to write the code again for this child class. You just inherit it from the previous class. In today's lectures, we're just going to explore till inheritance in object-oriented programming. So yes, this is an example where the employee employee name, department, resignation are the base class, and IFSC code and name are the child class. So the child class is going to take the properties of the employee class into itself. So we don't have to define stuff like employee ID, department designation again in here. So it's just going to like take these properties, right? This is another example. We define the base class as people and it has name, age, city, mail ID, department, etc. So this is the base class, right? And we take this base class and make its derived class. So these student, which is scholar, number, CGPA, are the properties of a student, but they are also people, right? So they are going to take the properties of this base class into the derived class. But why? This is why, because this is the most general description of a person, and these are more specific. For example, the student is specific and the faculty teachers are specific. The faculty needs to have faculty ID and designation, while student does not need these features. So that's why it takes these values which are common but doesn't take the other values. So these are made into separate classes which do not have other values. I hope that makes sense. Now we're going to learn about polymorphism. Polymorphisms comes from the Greek word poly, morphism. Poly means many and morphism means form. So basically polymorphism just means many formed. So polymorphism means the ability to take more than one form. For example, an operation have different behavior in different instances. The behavior depends upon the type of data used in operation. Different ways to achieve polymorphism in C++ program are function overloading and operator overloading. So basically what we do is, in polymorphism, we just like make a function, like a function which has the purpose of adding numbers, right? This is just an example, so just bear with me. Here's a function named as add, and it takes in general two values, a and b. So a and b are its parameters. Now what this function does is it makes another variable which just like adds these two values together, and then it returns, oh my god, why am I writing, and then it returns the value c. So basically what happens when you like make a program and you call this function like add, and then you pass on these two values, for example 1 and 2, but these two values are going to be given here, like 1 is going to be on a and b is going to have 2. So this is just going to c is going to add 1 and 2 and then return c, which is going to be 1 plus 2 is 3, right? So 3. Now when you call this, so that value of c, which is 3, will be stored here in this variable. Now this is just a simple function calling, right? What we can do in polymorphism is that we can just like have multiple forms, many forms. So we can make, oh my god, let me erase.
So it's a cookie block, but it's like one slider and two boxes. So if you look at two boxes, but there's like one slider.
Okay, so like there is a function add, it takes two values a and b, And then you can also define a function which is another add function, right? And it takes two values, a, b, and c. So inside this function you just add these two values, a plus b, and inside this function take you add three values, a plus b plus c. So what's going to happen in the program when you call this function, it there are two functions of the same name which are both named as add, but there are separate functions, right? So when you call this function inside the program, the control will go depending on what parameters you passed. For example, if you passed 1 and 2, then it will go to the first function because the first function has two variables in its parameters and the second has three, so it's not going to go there. So this is basically polymorphism, like you have the same name add and you can perform addition of two numbers or three numbers based on how many parameters you passed. Now binding. Binding. Binding refers to two things in C++, which it can be of two types, which are early binding and late binding. Early binding is when the function is called. For example, here is a function add and it's called. So in early binding, depending on the parameters, this function call will be attached to that function which has the same number of parameters. In early binding, which is at compilation time. So this is example of function overload, which is what happens in early binding. And then operator overloading is also polymorphism, so it's also similar. In operator overloading, it's basically you are using an already existing operator. For example, the the asterisk operator, which is used to multiply two numbers, and then when you overload this operator, you're basically like going to define another use for the asterisk operator. This use case can be anything. For example, you take a, b and add them, and then you take the resultant c and then you square it and then you divide it by 2. So you get me right. Operator overloading is also polymorphism because then we are doing multi-forms of the asterisk operator. So it's going to be like the asterisk operator has multiple uses, one of which can be like defined by the user. Now polymorphism are also of two types, which are compile time polymorphism and runtime polymorphism. Compile time polymorphism handles operator overloading and function overloading, which are both which is the same thing which I have explained just now. And runtime polymorphism covers virtual functions. So these are not
See, that's the thing. Different people have
defined at the compilation time, right?
in the meanwhile,
So this polymorphism
only the
is decided at the runtime, which is when the program starts running. Then only this is defined. This is used for virtual functions, which we are probably not going to handle in this lecture. Now dynamic binding.
there are questions like that, right? Like, it's kind of funny.
Dynamic binding refers to binding linkage of a procedure call to the code to the executed in response to the call. Dynamic binding means the code associated with a given procedure call is not known until the time of the call at runtime.
Why is my net so bad?
It is associated with a polymorphic reference, depends upon the dynamic type of that reference. So dynamic binding is basically runtime polymorphism, which is late binding. It's the same thing as late binding, which just means that it's not defined until the time comes. Then there is message passing. Message passing is nothing but an object-oriented program consists of a set of objects that communicate with each other. So like set of objects, for example student 1 and student 2. These are both objects which are going to communicate with each other by passing data. Message for an object is a request for execution of a procedure, and